Welcome back to the online class of Alpha School Padaparamba. Today we are going to discuss a new chapter, Polynomials. This is your second chapter. Okay. Before starting the chapter, we have to rewind some points such as degree of a polynomial and zero of a polynomial. What is meant by degree of a polynomial? Yes, degree of a polynomial means the highest power of the variable is known as the degree of the polynomial. Once again, in a polynomial, the highest power of the variable is known as the degree of the polynomial. According to the degree of a polynomial, we can categorize the polynomial as linear, quadratic, cubic, etc. What is meant by a linear polynomial? A linear polynomial is a polynomial with a degree 1. That is the linear polynomial. So, what is a quadratic polynomial? Yes, quadratic polynomial is a polynomial of degree 2. Similarly, cubic polynomial is a polynomial with a degree 3. Okay, so these are the points related to degree of a polynomial. Now, what is a zero of a polynomial? If we substitute values for a variable in a polynomial, in which value the statement becomes true, then that value is known as the zero of a polynomial. In another word, we can say that if k is a zero of a polynomial where k is a real number, then p of k that should be equal to 0. That is the condition. Okay. So we discussed or we rewinded 2 points such as degree of a polynomial and zero of a polynomial. Now we are moving to the first point of this chapter, that is geometrical meaning of the zeros of a polynomial. That is the first point of this topic. Through this topic, we can recognize or we can understand the zero of a polynomial by a graph. How we can calculate the zero of a polynomial? By a graph. That is the meaning of this topic. So here, first of all, we are going to consider a linear polynomial. Okay, as you know that the graph of a linear polynomial is always a line. That's why the name linear. Okay, so I draw a linear graph here. This is the graph and these are the axes, x-axis and y-axis. here you can see an intersection with the x-axis. Now listen, through a graph we can calculate or we can understand the zero of a polynomial by the point of intersection of the graph with the x-axis. Here the x coordinate is the 0. So this is the point of intersection, and as you know it is a point 2, 0. X 2 and y 0. Here we can say that the 0 of this line that should be equal to 2. Why? Here the x coordinate is 2. Now we can consider some more examples. Here a graph. 0, 1, 2, 3, 4, like that. The graph is drawn passing through the point. Here the point is -1, 0. And here we can say that the 0 of this linear graph or this linear polynomial that is equal to -1. Is it clear? Consider one more example. The graph is passing through the origin. And here we can say that the 0 of this line that is equal to 0, because the line graph is passing through the point 0, 0. So here the x coordinate is also 0. That's why here the 0 of this line is 0. Okay, now consider another situation. A graph and here the line graph passing exactly parallel to the x-axis. What about the 0 of this line graph? Here now intersection with the x-axis. Okay, so here we can say that there is no 0 for this line. Okay, so here we can conclude that a linear polynomial has at most 1 0. That's all. Okay. Yes. Now look at the board. Here we are going to consider the geometrical meaning of the zeros of a polynomial of quadratic type. First of all, what is the shape of the graph of a quadratic polynomial? That is not a line. That should be a curve like this. That is the shape of the graph of a quadratic polynomial. And that shape or that curve is known as parabola. Okay, anyway, here I drawn 3 figures. First, second and third. Look at the first graph. Here the curve intersects x-axis in 2 points. Is it clear? So here we can say that here this is a type of quadratic polynomial has two zeros. Why? Here we can see that there are two intersecting points. So here two x values. So we can say that this graph has two zeros. Is it clear? Now what about the second figure? Here the graph or the curve intersected x-axis in one point. So here we can say that this type of graph has only one zero. What about the third one? Here you can see that there is no intersection with the x-axis. So here we can say that this type of polynomial, quadratic polynomial, has no zeros. So we can conclude that a quadratic polynomial has at most two zeros. That may be 2, maybe 1, maybe 0. Okay, so these are the geometrical meaning of the zero of a polynomial. So once again I am repeating that by looking a graph we can simply understand the number of zeros of that particular polynomial. By looking the intersection, point of intersection with the x-axis, and in that intersection the zero is the value of x coordinate. Is it clear? Okay. Now listen, what about the zeros of a cubic polynomial? The graph of a cubic polynomial should be like this, and if we draw this graph, that may be like this. So here, how many points of intersections? Here 1, 2, 3, which means a cubic polynomial has at most 3 zeros. Is it clear? Okay. Now we are going to wind up today's class. Before winding up, please note your homework. Page number 8, exercise 2.1. Okay, that's all from today's class. Thank you. Have a nice day.